Okay, so we learn from nature. This one I have told you so many times.
Yes.
Okay, all this while we have been talking about the drag force. We are not talking about the lift force. Now, you know that for whatever force coming into the surface, it will be split into two, which is the tangential and the normal force. Okay, from those tangential and normal force, depending on the component, it can contribute to the drag or to the lift. So basically from one force, you divide it into two forces, tangential and normal. And then from those tangential and normal, each will contribute to the lift and the drag. So at the end, from those single force, you will have four force component, right? And those four force component will join to become either lift or drag component. So it is 1 into 2, 2 into 2, sorry, into 4, 4 into 2. So if you have force working on a body, you can split it into tangential and normal. From normal you get FD and FL. From tangential you also get FD and FL. So basically if you combine this, you get FD. If you combine that, you get FL. Okay, so this is how it looks like. Now, the form is the same, that FL is equal to CLA times the dynamic pressure. But the area is the platform area. This is the area that you see from the top. Okay, you see from the top. So, remember, we have several areas. First area is the frontal area, when you are having a drag force due to the pressure. Then you have this area, which is the area for the shear stress. Okay, and the platform area is actually the same area with your shear stress. This is the wing area when you look it from the top. Okay, in real life, you know that the area of the aircraft will be different, right? Because now if you have this Boeing 747, the wing will be like that. Right? It is not simply the chord, which is this one, times the span wise. Right? The span wise direction. So it is not simply this times that, but it has some angle. So this one, the area of this one, if you do this, it will not be taken into account. That's why nowadays, this one usually is given. Okay, coming back to here, if you are looking at the aircraft, you will know usually they will give you this one, okay, and then wing swept, and then the wing area. So this is the wing area is the one that you call it as a platform area. Basically, the platform area is not only the wing, the fuselage also they need to be calculated. Because this fuselage also provides the lift for the aircraft. Okay, some of it provide the lift for the aircraft. So now you know this is the aspect ratio. This is the wing swap. That's why you see that the aircraft now is not having a straight wing like this. If you are looking at the Cessna or Albatros, the old aircraft, or even the CH-130 Hercules, it have a straight wing. It has its own advantages, of course. It can fly at lower speed. Okay, some aircraft you need to fly it at low speed, like the survey aircraft, you need to fly at low speed. Okay, maintaining it moving at slow speed without stalling is also difficult, because those aircraft, the big aircraft, if you are moving at low speed, it goes down, right? Because later on you know that FL has half rho v square CLA. This velocity is the problem, because if your velocity is too small, your FL is too small, right? If your FL is too small, of course it will goes down. So designing an aircraft to fly at a slow speed can be as difficult as designing an aircraft flying at high speed. Designing an aircraft for a low speed is as difficult as you design an aircraft for a high speed. You know, usually you just think that designing an aircraft with high speed is more difficult. We tend to do that. Like when you design a car, you want it to be as fast as possible, and that brings a lot of complication, right? But in aircraft, designing aircraft that can fly slowly is also a problem. Because of this. If the velocity is very small, you need a very big wing, right? Or very big CL. So that's why some aircraft has a straight wing. Like if you know A10, it has a straight wing, right? Okay, A10 Thunderbolt, like this one, has a straight wing. See that? The wing is quite straight because it is used there just to loiter. Loiter means it's just moving around and around and around. If we found the enemy, it will shoot. Starving. Okay? Starving. And the ammo is big. If it hit you, this is enough to hit your head and your head is evaporated. So some of those is having a straight wing, but if you are looking at the Boeing 747, or this wing is not straight, it's swept, right? It's having a V shape. Okay, all those design has a different consideration. That's why you found it differently. Okay, usually a small aircraft will have a straight like this, a simple aerofoil, so you can see the chord and the span. Okay. Any question till now? At this point? Okay, if no question. Another important thing, rather than platform area, is the so-called wing loading. This is the average lift that is provided by your wing. How do you calculate it? It is FL divided by the area. So it will give you Newton per meter square. Just like your pressure. But it is pressure to the top. Okay? That lift the aircraft. And lift has to be equal to the weight during the flying at constant altitude. When you are not moving up and down, if you up, then your lift is bigger than the weight. If you goes down, of course, your lift is smaller than the weight. Simple physics. You get more lift, you get higher. You get lower lift, got lower. Okay, so simple story. Now, if you have done the experiment in the wind tunnel, you know that the airfoil has a different profile. Sometimes you have symmetric, sometimes you have non-symmetric. Okay, and the flow will behave differently. If you have symmetric like this, the velocity over here will be the same with velocity over there, which means this thing will only provide drag. There is no lift on this. But if you have this thing, the velocity over there is faster. Right? The velocity over there is faster. And you know by Bernoulli equation, the faster the velocity, the lower the pressure. If you have lower pressure on top and higher pressure at the bottom, of course you will lift. Right? Same with that. Okay? So, shape is very important in designing a wing. Right?